Hello! On this tutorial series about sprites on the Amiga computer, we are creating a ball that somehow recalls the classic Amiga Sphere logo from the 80s. In order to do so, with just a few short steps, we'll come from this to this. In the next video, we may show also how to make it spin and move. However, let's do a bit of preface. Like many platforms of that era, sprites used to be an essential hardware feature that developers were able to use for creating a game. Games like Turrican, Zool, Gods basically existed thanks to the sprites. Despite size and colors could vary according to platform hardware, the common advantage of a sprite is that it is an independent object that moves around the playfield. This means that in terms of programming, a sprite is easy to handle and costs a few CPU cycles. On Amiga, sprites has a limit of 16 pixels for the width. Luckily, have no limit for the height. Also, Sprite has 3 colors available, plus the transparent color. It is possible to use the attached mode for having up to 16 colors available, but it will cost one more sprite. Let's start now. Open paint.net and create a square image of 30 pixel size. Zoom the image in order to have a better control of it. Leave the background white. Start by creating red squares of 2 pixels, alternating with a white space. Use the copy and paste to make the process faster. What I want to do is to create a ball of 32 pixel size. It will cost 2 sprites, because, as I said earlier, sprite width is limited to 16 pixels. Once the texture is finished, we execute the Shape 3D plugin feature. We properly enlarge the ball image to fit the canvas as much as possible. We select the half sphere map repeat option item. We can also play with the 3 axes and see how the ball looks. I will adjust the z-axis to make it slightly inclined. We want to remove all the light effects because of the 3 colors limit. Now, with the ColorReducer plugin, I can see how many colors are involved. Indeed, we have too many colors on the image. By using the posterize effect, I will reduce the number of colors used in the image. We are almost done. I can use the Reducer plugin again and replace colors with existent ones. Here we are. With the help of the magic wand, I can replace the black with a transparent color. Finally, I resize the canvas to 32 pixels. The work here is done. I can save my sprite as PNG and pass to the next step. At this point, we have two choices. One is to use an external tool for converting the image into IFF, and then use a native tool for creating the sprite. On this tutorial we are going to use XnConvert and the IFF Converter. For the external tool I can recommend AmigaConv. It's a batch program that can convert graphics to Amiga format. Now that we open XnConvert, open the image we saved on paint.net. Add the action Change Color Depth. Select Colors 8, which is the minimum selectable value. On the Output tab, select Amiga IFF format. Click on Convert button to generate the output file. Now we can switch to the Amiga platform and load IFF Converter. There are plenty of IFF Converter versions, and they are all overall good. We load the generated IFF file from our Amiga hard disk. What we need to do now is to select the left area of 16 pixel width and save it as a sprite. I want to make sure the size is correct and the color depth is set to 2-bit planes. The option for color sprite will create a sprite data as a source format file. This is an example of sprite data. You can see the 2-bit planes are disposed in interleaved mode. By the way, this is how bit planes are disposed on standard mode. And this is how interleaved or row blit looks. This means we can also choose the row blitter option item and save the image as a binary file. Now we repeat the previous step and save the other half of the image as sprite. Now we choose the copper option item for saving the color data. Finally, we want to display the sprite on our program. This is a template I have created for starting with sprites. It already contains the basic hardware setup with pointers to bitplanes and sprites registers. You can check my GitHub page for further information and downloads. First, I define the sprite vertical and horizontal position. Consider that position 0 is not normally in a viewable region of the screen. That's because data is fetched after some pixel from the line start. I also need the sprite size in bytes so I can point to the other half of the sprite. Next, we can define the sprite data. The first few bytes define the Y and X sprite position. The V-stop is the first part of the sprite control register. For this case, we can leave the last byte to 0. After setting sprite position and control words, we can put the content data. Now it's time to put the second half of the sprite in the same way. Obviously, the horizontal position of this part is 16 pixels to the right from the first sprite. Notice the h-start value controls the horizontal position increments of 2 pixels. Thus, in order to display sprite in an odd coordinate, the byte 0 sprite control must be set. Now we have defined the sprite data, we can take care of their setup. This code makes the sprite pointers bind to the sprite data. looks like I forgot to add the sprite colors on my source code. Remember that sprites share the palette with the 5th bit plane. This means the same color registers are used for sprites and bitplane 5. Also, sprites share colors in couple, so sprite 0 and 1 share the same palette. Same rule applies for sprite 2 and 3 and so on. Here I forgot to swap the 0 again in order to correctly point to the next frame. That's it. If you find this tutorial interesting and you'd like to see more tutorials about sprites and Amiga stuff, please give me a like or subscribe to this channel. Thank you for watching this video.